Hey everyone, and welcome to this explainer. Today, we're embarking on a pretty awesome mission. We are going to meticulously deconstruct a single, incredibly detailed 8-second video prompt. We're looking at the exact blueprint used to generate a highly realistic broadcast scene using AI. By breaking this down, we're going to see exactly how setting, sound, and precise camera movement are explicitly engineered to build a vivid, living scene out of pure text. If you want to understand how to really talk to cutting-edge generation models and why you absolutely need to upgrade to use this specific model to get these results, this is exactly how it's done. So let's just dive right in. The blueprint begins with 8 crucial words. Intimate studio atmosphere, shallow depth of field. With just this tiny phrase, the prompter is immediately establishing a highly specific mood and visual depth. We aren't just asking for a generic picture of a room, right? We are dictating the exact spatial relationship between the camera, the subjects, and the background. This single instruction serves as the absolute foundation for the entire aesthetic we're building today. To really wrap our heads around how this works, we're going to dissect this prompt layer by layer, almost like a director's masterclass. First up, we'll look at setting the studio scene. Then, we'll design the diegetic sound. Third, we'll map out our 8 seconds of camera movement. And finally, we'll get into the technical generation specs. All right, let's jump right into layer number 1, setting that studio scene and dialing in the atmosphere. Think about the deliberate visual contrast engineered into the character design here. On one side, we have a young woman with long dark hair wearing an oversized sweater. On the other, the second woman has short, natural curly hair, and she's wearing a denim jacket. This is absolutely not random. By explicitly engineering this character design, the prompt ensures the generation model won't accidentally blend the two subjects together. It forces the AI to render distinctly contrasting textures, the softness of the sweater versus the ruggedness of the denim, the flowing dark hair versus the short curls. It's honestly a masterclass in establishing distinct physical presence. But of course, our characters need a world to live in. Think about the physical props detailed in the prompt. Condenser microphones on boom arms, gear, notebooks, and water glasses, all resting on a wooden desk. These aren't just background decorations, they're grounding elements. Specifying boom arms and water glasses gives the broadcast environment its authentic, lived-in feel. It tells the model, hey, this is a working studio, not some empty void. And apparently, even AI-generated hosts need to stay hydrated. Now, this perfectly illustrates how you bring that physical space to life, the lighting. The prompt outlines a highly specific 3-point lighting scheme. We have a warm amber desk lamp situated right between the hosts, casting this golden light across their faces. Then, right behind them, against a dark brick wall, a faintly pulsing pink-purple neon sign provides backlight. This creates a really warm, ambient halo and firmly establishes the studio's color palette. It's not just asking for good lighting, it's literally atmospheric painting with text. Okay, moving right along to layer 2, designing the diegetic sound. Because a truly immersive scene isn't just seen, right? It has to be heard. The prompt explicitly demands no music or soundtrack, opting instead for purely diegetic sound. If you're not familiar, that just means audio whose source is visible or implied right there in the scene itself. We're talking about a quiet room tone hum, the electrical hiss from the condenser mics, maybe the occasional creak of a chair or the soft shuffle of papers. By dictating these really specific, intimate audio cues, the creator ensures the digital environment feels tangible. It's the sonic equivalent of those water glasses on the desk. It completely grounds the scene in reality. Which brings us to layer 3, mapping our 8 seconds of camera movement. This is easily the most dynamic part of the source material. We aren't just generating a still image here. We are orchestrating a single, continuous take choreographed flawlessly over exactly 8 seconds. Look at how precisely this timeline is mapped out chronologically. From 0 to 2 seconds, the camera holds a wide 2-shot, establishing the opening frame and showing both women at their mics. Then, from seconds 2 to 5, the camera makes a slow, smooth push-in toward the desk, slightly favoring the speaker on the left as she leans forward. Finally, from seconds 5 to 8, the camera settles into a comfortable medium 2-shot to capture the right speaker reacting. The camera isn't just recording, it's acting as a narrative tool, actively emphasizing the mid-conversation dynamics between our two hosts. Let's look at this next detail and see how it completely builds on that camera movement. During that crucial push-in between seconds 2 and 5, the prompt specifies neon sign blurs pleasingly in the background bokeh. Remember what we talked about earlier, that shallow depth of field? Well, this is exactly where it pays off. As the camera pushes in, the prompt forces the lens to shift focus, intentionally blurring that pink-purple neon sign into soft bokeh. It tells the AI exactly how the virtual lens should behave, creating cinematic depth literally right before our eyes. Now, alongside the camera movement, we have the human element. The left speaker leans forward, her mouth moving to make a point, while the right speaker nods and smiles in a really warm response. But the absolutely most vital instruction here is that last point. Face identity remains stable across the full take. When you're generating continuous video, explicitly stating that facial identity must remain stable is a strict technical necessity. It ensures these remain the exact same people from second 0 to second 8, preventing them from, randomly morphing or growing a third eye mid-sentence.
And that brings us to our final layer, layer 4, the technical generation specs, the hard data.
The exact metadata maps out a duration locked at 8 seconds, all in a standard 16:9 widescreen ratio. Native audio is set to true, which allows those intricate diegetic sounds, the chair creaks, the mic hiss, to be generated natively alongside the visuals. And finally, the engine running this whole operation is the Cadence 2.0 fast model. Honestly, this is why you really want to upgrade to use this model. It's this precise combination of hard technical specs and highly descriptive text that Cadence 2.0 Fast uses to successfully build our stunning final output. Oh, and as a final layer of polish, the parameters specify the Gempix enhancement style as classic. Think of this as a final color grade and rendering pass. It takes all those warm amber lights, the background bokeh, the denim textures, and unifies them into a polished, cinematic look that feels completely ready for broadcast.
As we wrap up this explainer, I really want to leave you with a question to chew on. How does exact timing and diegetic sound change the way we actually experience an 8-second broadcast? Think about it for a second. It's not just about asking an AI to draw a pretty picture anymore. It's about meticulously stacking variables, authentic soundscapes, dynamic lighting, and precise second-by-second camera choreography to create a synthetic scene that feels undeniably human and compelling. The next time you see a stunning piece of generated media, ask yourself, what invisible script is running behind the scenes to make you believe it? Thanks so much for learning with me today, and keep exploring.